What would you say were the hardest parts of building a compiler targeting Bitcoin script?
Yeah, that's a great question. Because when I first started out writing the compiler, I was just, that's not much. Because if you take any kind of computer science, program, as part of the course, you need to build a compiler. So I suppose everybody can build a compiler for some kind of like a small language. But for Bitcoin's script, it's very unique in the design, which should make it more difficult. One, there's no memory, there's no storage, there's only stack. It's very unique. For all the other virtual machines I know, you have storage, like a memory, right? You can store it and then you can load it later. Basically, you write it and then you can read it later. In Bitcoin world, it's not. That's only stack, okay? And it has two stacks called dual stack: the main stack, the auto stack, or called the control stack. Okay. Number two, you don't have so-called call function call primitive. Like usually you have some kind of like you can define routine and then you can call it with some kind of like a jump. There's no jump instruction. So it's very difficult to implement function call. But also it's for good reason. It doesn't have jump, because if you can jump, you can never know whether you will stop. In the Bitcoin world, it is a nightmare. You have everything so-called has to be, in computer science terminology, it has to be decidable. It's going to halt. So that's why you have to, minimize the number of what kind of instruction sets opcodes you can have. So it doesn't have jump. So you have to figure out how to do function call. Basically, you inline the code. So whatever code you're going to call, you just copy all the whole function body there, copy paste. So that's how you have to inline everything. Three, I think one of the biggest complaints, there's no loop. Okay, right? Because also there's no jump. So not only you cannot easily do function call, but also it's not easy to do loops, especially unbounded loops. But also unbounded loops, you can never have that in Bitcoin world, right? Imagine you write a program, it's like you loop forever. It's never the Bitcoin just stopped. It never want to have that happen for good reason. So all of this is very different from any other virtual machine I know of. So you have to come with new ways. For example, if you do loops, even at the CPU level, right? How do you do loops? If you loop 5 times, you basically run the same code 5 times, right? So for us, every loop has to be unrolled, for example, unfolded at compile time. Basically, if you want to run this piece of code 5 times, you just copy paste 5 times. You expand it at compile time. So that's also very unique. And you should never have unbounded loops. You can never say, hey, if this condition is true, keep iterating. Never do this in Bitcoin because it may never stop, right? So but all this can be overcome. Basically, eventually we find out ways, and then we make me appreciate more about the design, because it may look very cumbersome at the beginning, but then eventually when all this to make sure the script always terminates. Because if as any script does not terminate, is a disaster for it. Bitcoin basically it just keeps looping, and it's not a server you can just restart, right? Because it's a global consensus network. If one gets stuck in a forever loop, everybody is stuck in a forever loop, and every transaction gets stuck. And I don't think it's easy to restart. So it's all good design, but then we just to get around so-called, I wouldn't say limitations, it's just a uniqueness. We have to, get around it. And eventually we fix all those issues, and it works very good. Yeah.